See Standard 10th Maths Chapter 7 Mensuration Exercise 7.4 Sum number 8. A hemispherical bowl is filled to the brim with the juice. The juice is poured into a cylindrical vessel whose radius is 50% more than its height. If the diameter is same for both the bowl and the cylinder, find the percentage of juice that can be transferred from the bowl into the cylindrical vessel. See, hemispherical bowl and cylindrical vessel. So, two figures they have seen here, cylinder and the hemisphere. See, first let me take the cylinder. Cylindrical vessel whose radius is 50% more than its height. So height is, measurement is not given, so just you take it as h units. So radius is 50% more than its height. Already height is here, 50% more. So 50 by 100 h. That is h plus 1 by 2h. Take LCM, 2 is LCM. 2h plus h, 3 by 2h units. So the radius r of the cylinder is 3 by 2h units. Come to the second line. If the diameter is same for both the bowl and the cylinder. So here this is the radius. Diameter is same they given. So in that case, the radius is also same. Both the diameters are same, means the radius also same. So what about the radius of the hemisphere? Let me take this as h1. This is same as the radius of the cylinder. So 3 by 2 h units. H units. Okay. So now find the volume, because see the percentage of juice that can be transferred from the bowl into the cylinder. Juice is transferred into the bowl to the cylinder. So volume V of the cylinder is pi r square h cubic units. So keep pi as it is. R is 3 by 2 h the whole squared into h, that is pi into 9 by 4 h squared into h, that is 9 by 4 pi h cube cubic units. Let's see what about the volume of the hemisphere. You find the volume of the hemisphere. V is equal to 2 by 3 pi r cube. So differentiate this r1 cube, cubic units. So 2 by 3 pi 3 by 2 h the whole cube. So 2 by 3 pi 3 cube is 27, 2 cube is 8 h cube. So you can cancel this. 9 times it goes here, 4 times it goes. 9 by 4 pi h cube, cubic units. See, look at here, the volume of the cylinder and the volume of the hemispherical bowl, both have the same volume. So if I pour the juice from the hemispherical, if I transfer the juice from the bowl into the cylindrical bowl, so there won't be remaining juice because both the volumes are equal. So mark this as 2 and this as 1. So from 1 and 2, volume of hemisphere is equal to volume of cylinder. Therefore 100% of juice can be transferred from the bowl to the cylinder, to the cylindrical vessel. See, next is example 7.31. A right circular cylindrical container of base radius is 6 cm and height 15 cm is full of ice cream. The ice cream is to be filled in cones of height 9 cm and base radius 3 cm having hemispherical cap. Find the number of cones needed to empty the container. So in the cylindrical container whose radius is 6 cm and height is 15 cm. So height is 15 cm. Radius is 6 cm. First you keep this cylinder. Cylinder radius is 6 cm. Height is 15 cm. So it contains full of ice cream. From this container we make the cone ice cream. The cone ice cream is, the base is cone shape and it is surmounted by the hemisphere. So one cone means we include cone and the hemisphere, that is volume of cone and volume of hemisphere. So this makes one ice cream. So here the height of the cone they given us here for you, from this to this 9 cm and the base radius is 3 cm. The same radius is for the hemisphere also. Okay, so how many cones I can make? So first I'm going to find the volume of the cylinder. This contains this much of ice creams. So volume is equal to pi r squared h cubic units. So pi, keep pi as it is. R is 6 into 15. So you just multiply this. 540 pi cubic centimeter. Now come to the ice cream. Ice cream is, it has two solid spheres. One is cone and the other is hemisphere. Ice cream. One is cone shape, another one is hemisphere. So cone radius is 3 cm and the height they given us 9 cm. Hemisphere same radius, r is 3 cm. So volume is here 1 by 3 pi r squared h cubic units. This volume is here 2 by 3 pi r cube cubic units. So 1 by 3 pi r is 3 into 9. 3 cancel. 9 3s are 27 pi cubic centimeter. Here 2 by 3 pi 3 into 3. 3 cancel. 3 3s are 9. 9 2s are 18 pi cubic centimeter. So these two figures makes volume of ice cream. Volume of ice cream. Volume of cone ice cream also you can take. Is equal to 27 pi plus 18 pi. That is equal to 45 pi cubic centimeter. So what is the question here for you? See, find the number of cones needed. That is cone ice cream. So number of cone ice cream is equal to volume of the cylinder divided by volume of the cone ice cream. So what is the volume of the cylinder you have got here? 540 pi. 540 pi divided by volume of the cone ice cream is 45 pi. 45 pi. So pi cancel here, and then this goes here one time, remainder 9 carry over 9 two times. So 12 cones. So the number of cones are 12. So 12 ice cream cones or cone ice creams are required to empty the cylindrical container. See the next example sum 729. A metallic sphere of radius 16 cm is melted and recast into small spheres, each of radius 2 cm. How many small spheres can be obtained? See, a metallic sphere is melted and recast into small spheres, small number of spheres. In that question, how many small spheres can be obtained? So we differentiate the spheres as bigger sphere and the smaller spheres because both are different radius. Bigger sphere and the smaller sphere. So bigger sphere radius R is 16 cm they given, and differentiate this R1 here. Small sphere radius is here 2 cm. See, volume of this bigger sphere is 4 by 3 pi r cube, cubic units. What about the volume of the smaller sphere? Same 4 by 3 pi r cube. So differentiate this r1 cube, cubic units. So 4 by 3 pi into 16 into 16 into 16. Here the volume V is 4 by 3 pi into 2 into 2 into 2. So question is how many? Find the number of smaller spheres because we derive the smaller sphere from the bigger sphere. So number of spheres. Smaller spheres, you take smaller spheres, is equal to volume of bigger spheres divided by volume of smaller spheres. Volume of smaller spheres. So this is equal to, just write 4 by 3 pi 16 into 16 into 16 divided by volume of smaller sphere 4 by 3 pi into 2 into 2 into 2. So this 4 by 3 just cancel, pi cancel, 2 in 16 it goes 8 times. Again this 2 here it goes 4 times. Again it goes here 2 times. So 2 into 16 into 16. So 16 into 16, 256 into 2, 512 spheres. This is the answer. So therefore, how many spheres can be obtained? So 500 small spheres. There will be 512 small spheres. See, these two example sums are very important one, and this is the easy method of doing this calculation also. So I hope you could understand these two problems very easily. Thank you.